All right, so this is the combined gas law labs. You want to follow through the procedure. So as you can see, I've got some boiling water here. I've got this nipple up into the top of an Erlenmeyer flask. This was completely empty, this Erlenmeyer flask. Well, except for air, of course. So what I'm doing now is I'm heating that Erlenmeyer flask up. I'm going to let that happen for about 5 minutes. While that's going on, I'm going to show you what I have back here. There's a bucket full of cold water. Actually, it's room temperature water. We know this is close to boiling, but we're going to take the temperature of that as well anyway. And basically what I'm going to do is I'm going to take this gas, put my finger on there to close that gas in, and I'm going to take it over here and lower the temperature of it. When I lower the temperature of it, we know that the volume of that gas should decrease. I'm going to then find the actual measurement of the volume of that gas, which I will call V2. I'm going to compare them. The temperature of this will be my T1. The temperature of this will be my T2. And the pressure of this gas is equal to the pressure of the room. So I'm going to show you how to get the pressure of the room and the pressure of the gas afterward, or what we call P2. Since I'm collecting it over water, we've got to actually use Dalton's law to subtract off the vapor pressure of the water that will actually get up in there. So those are the things that are going on. I'm going to pause this for a few seconds to let this heat up for 5 minutes. All right, so this is a barometer. So what we want to do is we want to get this mark right here. We want to get that up onto the temperature so that that's perfectly on there. And then we're going to read the pressure here. So there you can see it is between 775 and 780. So each of those marks then is 1. So these actually read from 775 to 780, so it goes down. So 776, 777. It looks like it's between 777 and 778. I think it's right there at like 77.9. So that would be our P1. So let's take a look over here. Go back to our laboratory setup. There's our big bucket of water. This has been boiling for about 4 minutes now. Well, it's splattering a little bit. So let's quickly get these temperatures. I'm going to get the temperature of this water, and then I'm going to basically move it. So we drop that into the side there. I want to keep it on the water. I don't want to touch any of the glass. Keeping that right on the water. This thing's a little slower. We need an insta read. So all right, we're showing it is boiling, but this could be impure water or the pressure today. Well, 777 is higher than 1 atmospheric pressure. So let's give it one more second. And I think that's where we're going to call it, 99.7 degrees. See if it stays 10 seconds. Yeah, right? 99.8 degrees, I think. It's right there on the line. So 99.8 degrees Celsius for that. Cool. Now we'll take this and move this. So I'm going to loosen this. I'm going to cap this. And I'm going to move this whole thing over into here. Once I get the nipple down underneath the water, I can actually let go of it. I'm going to move the camera over here so that you can see that. But I'm going to get this junk out of the way first. So let me go ahead and I'm going to pause it for you. So now here is our gas. So we need to get another temperature reading of this. Make sure you guys can see that. $25.7, 25.8. Here we go again, right? Give it 10 seconds. Yeah, we're right there on 25.7 and 25.8. Let's go ahead and ooh. Oh, it's holding at 25.9. Wonder what the temperature of the room is. Let's do 25.9 for that, because it's going to start dropping after that point because the room is actually colder than 25. So I'm then going to remove this, what's called a sidearm clasp. Boom. I'm going to put my finger back on the bottom of that nipple, and I'm going to tip that over. So now we have a certain amount down here, and I need to figure out how much that is. In order to do that, I'm going to use a graduated cylinder. And I'm going to tap any water that's in there just to make sure. Take that cap off, and I'm going to pour that into the graduated cylinder. So if we take a look at this reading right here, a little out of focus. Maybe we can get that to focus better. Focus. That's done. It just went a little bit past, didn't it? Let's see if I can get it better. Boom. Now, that is not 100% level, and unfortunately I don't think I can do that with this camera. I don't think I can get like it level because it won't turn one way that I need it to. So I'll just have to give you the reading. I can see some air bubbles in there. I'm going to tap those and see if I can get those up. Nope. Oh, that's going to just have to be some air that we have then. So we have 55, 56, 57, 58. It is at 58.1, I believe. Let's go 58.2. 58.2. Now the mistake that a lot of people do is they put that as their volume 1. That is not the volume 1. It is actually not the volume 2. This is the volume of the water that's entered the flask. 58. 58.1. I'm going back on that. Sorry. 58.1. 58.1 milliliters entered this flask. So now we've got to figure out V1. Now this is kind of interesting because the way you do that is you fill up this entire thing, and I like this part because it's kind of funny. I'm going to readjust you here and then refocus you. Since I have this nipple, that has some air in there. I need to get that filled with water as well. So we pop that nipple on and we press up, and then we carefully remove this. And I want it to be on there just as it was whenever I started. I'm going to need a bigger graduated cylinder for this. So I'm actually going to pause this and get a nicer one. I'm going to get a glass one. Well, unfortunately for me, I could not find a glass one. So we'll go ahead for it. Just going to pour all that water in there. Tap the edge to try to get any water bubbles off of there. So this is 250 right here. That is 300. So that means that each of these marks, 250, 10, 20, 30, 40, 50, 60, 70, 80, 90. So 250, 270. I'm going to say it's right there on 280 dot. 280 dot. So that is volume 1. 280 dot. Very cool. So you have the P1. Oops, let's do this. You should now have, you're upside down. You should now have the P1 from the original barometric pressure reading. By using this table right here, these are the vapor pressures. By knowing temperature 2, that's the temperature of the bucket. You'll find the vapor pressure of the water and be able to subtract that from P1, which is barometric pressure. And you should have the original temperature of the hotness. Then you actually use this as your experimental. And then right here, you actually calculate V2 using all the other variables except for this. And then you know you can calculate the actual here by knowing the full volume and then subtracting out the amount of water that actually went into it. And then last but not least, you are to figure out by knowing the actual from the laboratory minus the theoretical divided by theoretical. That will give you the percent error. This will be your lab partner's percent error, Mr. Jackson, today. So hopefully it's not too bad. Thank you, and I hope you enjoyed it.